So, all right, as I mentioned before, the difference between sequence and series. Series is actually when we add all the terms in the sequence together. So a series is the sum of a sequence. So I suppose we could formalise that by saying, well, term 1 plus term 2 plus term 3 up to term n would be the sum to n terms. We could also use sigma notation. So remember, capital sigma stands for the sum of. And so we're saying, okay, there's our general term, and we're going to add up all the ones from 1 to n. The only thing to be careful with when it's in sum notation is make sure you read where it starts, because sometimes they might say the sum from, say, oh, I don't know, let's say k equals 5 to n. So they want you to start at the 5th term rather than that. So, okay. Well, it's an arithmetic one because we can see that the general term is a linear function. So we know this one's arithmetic. And let's work it out. There it is. 2 plus 3, 4 plus 3, 6 plus 3, 8 plus 3, 10 plus 3. Later on, of course, we'll find a formula to do this. But at this stage, let's pretend we don't know a formula. And that all adds up to be 45. They've told me sum of the first 10 terms is 29, but the sum of the first 11 terms is 37. Well, that, of course, allows us to find the 11th term. Because how did I go from sum 10 to sum 11? I must have added on the 11th term. So I could say that term 11 would be the sum of 11 minus the sum of 10. So in this case, it would be 8. So using that idea, if we've got a formula for the sum to n terms, we should be able to work out a formula for the general term. Because we could use the same idea and say, well, hang on then, term n would be sum to n minus sum to n minus 1. If I take away all that sum to n minus 1, I'm just going to be left with the nth term. So sum to n, they gave us the formula, 5n squared minus 2. So if I now replace n with n minus 1, I should get sum to n minus 1. So a little bit of tidying up to do. Expand that all out. Add like terms, and there we go. We get our general formula there of 10n minus 5 for that particular pattern. We actually have got formulas we can work out for the arithmetic series, well, geometric as well for that matter, but let's do arithmetic first. So there would be the sum to n. I could say, well, it's the first term plus the next term, or the next term would be a plus a common difference. Then it'll be a plus 2 common differences, and I could keep going and keep going. And I'll just call the last term L for last. So the second last one must have been L minus the common difference. Then the third last one must be L minus 2 common differences, and so on. In fact, that's so good, I'm going to write it again, but backwards. And by doing it that way, hopefully you can see a pattern emerging. If you look at every spot, we've got A plus L, but then we've got D minus D, so that's going to disappear. A plus L, 2D minus 2D, that disappears. So that all the way along, I'm going to get A plus L, A plus L, A plus L, A plus L, and so on and so on and so on. But all those D's will end up cancelling out. So I guess the question is, how many A plus L's do we have? Well, we must have n of them, because we know each one of these represents a particular term, and we know there's n terms. Well, that's what twice the sum, because when I added them simultaneously, the two sum to n's would add together to give 2 sum to n. So if I divide by 2, there's the formula, which I hope we recognise. We do remember the formula. But anyway, there it is. That's where it comes from. And that's handy if we know the last term. If we don't know the last term, well, then all I've got to do is substitute in the general term for the last term, which is a plus n minus 1d, and we get an alternative formula, which is n on 2, 2a plus n minus 1d. Now be careful with that. It's so easy to make a mistake and just go a plus n minus 1d, because that's what we're used to with the general term. But for some, it's 2a plus n minus 1d. But, so let's use those. This particular pattern, the first term's 3, the sixth term's 96, find the sum of the first 6 terms. Okay, I'm going to use the a plus L formula, seeing we know the last term. So, well, just a basic substitution question. 6 on 2, 3 plus 96, and we get 297. find the sum of the first 100 even numbers, and let's just pretend for a sec that we don't know what that last even number is. Too hard to work out. What is the 100th even number? Don't know. So we'll use the other formula. First term's 2, the difference also happens to be 2, and we've got 100 of those even numbers. So I can plug it into the other formula, the 2a plus n minus 1d, sub it all in, tidy up, there it is, 10,100. The sum of the first 10 numbers is 100. The first 5 is 25. So let's find all the sorts of things we like. The first term, the common difference, a formula for the general term. So sum to 10 is 100. So that means 10 on 2, outside of 2a plus 9d is 100, which I can tidy up. Okay, there's one equation. 2a plus 9d is 20. Sum of 5 is 25. So that'll be 5 on 2, 2a plus 4d. All right, 2 equations, 2 pronumerals, should be possible to find them. So what one will I eliminate? I reckon I went for the a's. That's going to be easier, isn't it? Yep, let's make the a's the same. So I've got 2a plus 9d is 20, 2a plus 4d is 10, giving me that 5 common differences is 10. So we now know the common difference is 2, sub back in, the first term must have been 1, so now we can work out the general term. A plus n minus 1d is up to be 2n minus 1. 2n minus 1. And that's all the info they wanted. So A is 1, common difference is 2, general term is 2n minus 1. Now, when you're solving a question like this, write your conclusion. Don't just leave your answers hanging around everywhere and go, oh yeah, but look, I wrote term n over here, I wrote the difference over here, I wrote A over here. Make it easy for whoever's marking your work. Okay, so here it is. There's my conclusion. That's all the stuff you asked me to find. Sigma notation. Again, I notice it's a linear function, so I know it's arithmetic. And seeing it's in sum notation, I may as well use the A plus L formula. The first term, when I sub in 1, will be negative 3. The last term, when we sub in 10, will be 24. And we've got 10 terms. So we'll just sub it into our A plus L formula and 105. Okay, that'll do us for today. Oh, in sum notation, if I did start from n equals 3 and say I was going to 10, how many terms have we got? 8. Because remember, it's inclusive. And 7 would be the common mistake, because you're just going, oh, top minus bottom. But remember, it's inclusive, so you've got to add 1. So be careful with that.